Hey guys, hello and welcome to a new video. This time a case solve from the Ben tournament. This time from Benni. And yeah, this case went well. I made a small mistake on a later level and it was a little bit slow, but besides that, only Jean was better. Unfortunately, I made this mistake, so not better than Jean, but yeah, let's see what this case will bring us. So here, this is an easy mid. Then this is I use my lambda, but you can also use a len then substitute combination. You have to watch out for the upper and lower casing, but therefore I have a lambda count letter in text. This is the text, this is the letter, non-case sensitive. And we're good to go. How many people match either the first name or the last name? So a text split. And then, oh no, I use filter. Filter the order if the first name is either Benni or Mary in this case, or, and this is the or operator in Excel, the name is Lindner, not Christian in this case. And then rows. And with count if as, you have to watch out for people with the same name as here given, and therefore at least would have need to subtracted at least one. Given a part of a name that appears there, nickname tab. Okay, so basically what we have to do is we have to search for this part of the name within all names. This will give us out value and something else. Then wrap this in an is number, by row or, and then some, no, not some minus, xlookup true in for this by row, and as the result, first name and space and last name. And this should work. Yes. How similar are these names? We do this on the data table. Okay. Last time it has worked. It's not the most stable thing. Here it goes. How similar are those two names? So first text split, then max len, and then similarity is counted longest same letter combination. So first generate the combination sequence len of this in rows, and for this sequence len I know I have to len of this, but in columns. And this gives us here those names, and you see we have here from the back, we have from the front, we have all combinations. We have them maybe multiple times, but does not matter for my stuff. So, and this is P for part, L for len of part. And now we search for part in the other name, which gives us either value or something else. And then we use is number, which gives us true and false, and multiply L by its number, and then the max of all of this is our result. In this case 2, which is right. And then we do round 2 divided by 9 multiplied for 400, rounded to the nearest decimal. 22 is given. And everything is correct. How often does the given first name appear in the dataset when you consider each similar letter? So in this case, data table. So let's generate the different version of Lucas. In this case, we substitute Lucas against here this letter against similar letters, but we have to do this multiple times. So we stack all of this because we also have to do the other way around. So I again is H, and also in this case for this level it's not important, but might be important for other levels. We have to substitute also the first letter, so the uppercase letter. And here I recommend to use proper for both and not upper, because with upper you will have problems because of the CH. And then also the last version is this with the other way around. So H, I. And then I use my unique pro, because unique is not case sensitive, unique pro is. And these are then all versions of Lucas, or possible versions that are possible with all of this. And then we use count if s, first name, yes. And the count is 22. We have a few zeros in there, but they do not matter with count if s. Okay. Should be all right. And yes, we have this level correct. And asset, because here we have Christoph. If you take Christoph and take a look at this table here, CH. And my approach was, what was giving me the error, to use upper on both. So upper on this and on this. And if you then do substitute this with this, returning this, you will not get Christoph with K. Because here the first two letters, even though he has only one letter, so with proper, you also get a Christoph with K. And that was the issue. Those two letter combinations, by using upper, I've destroyed the case sensitivity in that regard. And yeah, that was destroying and costing me 14 points. In this case, too much. And now level 7, which looks super not understandable. So the wording, it took me a lot of time. But it's basically just a combination of level 5 and level 6. So, we first split this. Because why not? So, same letter combination of their names. Now, we do here the following and generate a lambda with or a robot. Generate lambda statement. Complete with work. Taking long. And I also have to corrected in the end. So yeah, because it will, yeah, here it goes. Yes, not returning correct because of this. No, it's returning a correct thing. And I don't need this. I can also use this let. Yeah. X. And then here. So here for Stephanie and Steffen, it would be 38. No idea if this is correct, but now we also have to do the letter combinations. So among all similar letter options, there are 4 name pairs that yield consecutive letters. So here, if we swap all stuff out, and therefore I use this version here, which is I think this should yield the correct thing, but let's see. X, yeah, and then map this. It was late last night. I'm not 100% sure that what I'm doing is correct, so a little bit of guessing here too. Value, that's great. Okay, the question is why. Okay, let's just do this. No, it's okay. Find the longest number of both names for all consecutive letters. Found using a similar letter adjustment, reduce the total combination length by 1.5. For consecutive letter combinations, select the combination with the longest letter. Okay, I don't think that's incorrect. It's not step 1. It's not step 2. It's not step. Is it step 3? Yeah, it might be step 3. Yeah. And then if it's unequal to the beginning one, then 1.5, otherwise 0. And then this minus this, 2.5. Now try to map this. Now we can name this lambda underscore step 1. And then delete this here. Which was spill. Yeah. Here we go. This is spilling. And then we need to have max lang 8, and then round this divided by 8 times 100 rounded to nearest decimal, 44. Yeah, max should be, yeah, there was yeah, okay, because no, okay, 129, that's not correct. What is going on here? Minus 25, 0. Okay, there's something odd in here. Although it is 0. Interesting. Might be correct. If not, seen that yesterday. Yeah, it's all correct. Okay. Weird that I have not spotted the zeros there and investigated yesterday. But anyways, longest first name, max lookup, len of first name. In here, xlookup and max combined. Christopher, most common last name, CMV, No, it's count most of, not char, single result and large data set. Max value, Martin. There are two pairs that share the exact same name. Highest name strikeliness for all four of them. Most of value in area large data set, and then we simply combine those both names. Hopefully it will not explode. So here Anna Richter and Sarah Schmidt. X lookup. Oh no, this is too much. Oh no, it's not, because it's 4 lookups. X lookup, Anna Richter in first name, and yeah, in the calculated column would have been better, but for the sake of speed. And then return the name strictness. 94, and then the same, but from below. Last first, and then the maximum is 94, which is asked because highest name strictness is asked. So max of this here. There's one letter in the alphabet used the most times across all names in the data type. How many of the 1250 names do not include that most common letter? Most of jar in area large data set. Case sensitive, no. Knorr spaces, yes. So the A is the most common letter. And if we filter the order number if do not include. Okay, we should have had a calculated column. Now we do it. And then we search for A, and this is case insensitive. So sum minus not is number. Should be the solution. 287. Yes, correct. How many people first name match the regex pattern of the case author's first name? Thank you, Benny, for the regex pattern. I would not have been able to bring this up, and then we do regex test. First name, yes, regex pattern is given. I tested both. Case sensitive and case insensitive does not make a difference, thankfully, but I can show this. So default case insensitive, sum minus, yeah, 30. And now if we make this case, default is case sensitive. If we make this case insensitive, it is still 30. So yeah, I think Benny has tested this. And then 30, and we have solved everything. So an interesting case, not too much theming around this, but yeah, especially having a little bit of text manipulation, which is not done that often, even though used a lot of times in reality, is always a cool case. And yeah, I think we're at this point in esports where we also have to think deeply or involve deeply case sensitivity in all cases, because we're not, I don't think we're running out of topics, but exploring new stuff, because in Amsterdam case sensitivity was also important, so here it is too. So yeah, watch out for that and learn a bit about it. So anyways, thank you the Bens for this tournament, thank you Benny for this case, and thank you for your time. See you next time. Bye.